We will solve the first problem, that is computing volume from cross-sectional areas. Now over here we have a problem, that is the Pyramid Arena in Memphis has a square base of side approximately 180 meters and a height of approximately 100 meters. Find the volume of pyramid with these measurements. The figure is given over here. There are various methods to solve this. Now, which I'm teaching is one of the method, and I feel this is one of the easier method and simpler method rather than solving a lot and getting the answer. Now, if I'm showing you 1 second, I'll just show how much is this. Just finding the S equation, that is the side equation, area, substituting the value, and you'll get the answer. This is much concised way of solving. We will solve one by one. Now, before we go to the step one, I want to tell you a few things. In these type of problem, you must see what is given in the question. Here they have told square base. Now, area of square is side to the power 2. So you should know it's side square. If it was say circular base, then it will be pi r square. If it is rectangular, then length into breadth. It depends on the question. It will be mentioned in the question. Okay. Now, this one over here is a square pyramid. It will not be as conventional problem solving because it's not exact coordinates. You can't just put this as 0, 0, 0, 1. Now, you need to apply a lot of things over here. Because this is a square pyramid, this is a 3D object, you need to understand this in a different way to get the coordinates. So, analyzing the graph, that is this, diagram, analyzing the figure, find the coordinates at the base and the topmost height. Okay. Now what it says is, what is this coordinate point? Now over here you must understand the side is 180. Okay, the side is 180 meters, but the height is 100. From here to here, the straight height is 100. So let's write the coordinates over here. See, this is the x, right? They are mentioned over here. So let us take the height as, don't get confused over here, since this is mentioned as x, we'll take this as the height. 100 meters. And now this point is like a, if you see like a 3D view, this will be basically 0. It's the beginning. Okay, this is the beginning. Now over here you're getting 100. This is 0. Now let's just see like this. This is the height. So this is upwards is the x over here. So 100 is written over here. Now over here you're starting the values. So this is the initial 0. Now what is happening over here? It's 180. Why? Because the side is 180. From here when you're going to over here, this value which is 0 will increase to 180. But now here you're going downwards, so this will be again 0. Okay, so it's going downwards. You must see like this, downwards. So the topmost height 100 comma 0, because this is the initial point we are considered, and this the side is 180 but height is 0, bottommost point. So another way to understand is topmost point height will be 100. Okay, and then the side distance is 0. Here bottommost point 100 base, right? 0 is the height, and then this is 180 because x is upwards. Now this just varies because it is a three-dimensional object. Now the sides of the square base must be a linear function to be solved. Now here you can see it's a straight line, linear functions, right? We know linear function is given by y is equal to mx plus b, where m is the slope. If you find this equation, that is the side, then you can easily square it up to find the area. So to find the cross-sectional area in the step 2, first you need to find the slope. How do you find the slope? By using this formula, y2 minus y1 divided by x2 minus x1. Now let us apply over here. See, this is the initial point, so I'll take it as x1 y1, x2 y2. Now what do we do? Apply in this formula. When we apply, we will just see it is 0 minus 180, y2 minus y1, 0 minus 180 divided by 100 minus 0. The answer is over here negative 9 by 5. Now apply it over here in this particular equation. Okay, this is simple. For starting part, side, that is side, 9 minus 9 by 5x. But what about this 180? This is the intercept, y-intercept. When do you get y-intercept? When the first value is 0, isn't it? Now, there are other methods to solve, but since it is directly given over here, just substitute, just see over here, the first value is 0, whatever is the answer, that is the y-intercept. Otherwise, you can use test values. Okay, you can just substitute over here y as 0 and x as this point, and then solve it, you will get the answer. But since you know this is the intercept point, okay, that is the answer because this is touching the axis. That is 180. Always remember, when the first value is 0, the next value, that is the y-intercept value. Next, what would be the next thing? Area A of x is equal to s square. This is given. This is the given equation. That is the side. Sorry, this is not the given. This is the side. Over here, A of x is required to be used in the formula. So area of a square is side square. What I meant by given is the square is given. So we need to use s square. It is mentioned in the question. So we are using side square as area. The area equation is found out, so square it up. Now all you need to do is substitute in the formula. So a to b is the interval a of x into dx over here. Now what is the interval? See, from here to here, the dx, right? The height. It's basically you're finding the cross sectional. See, like this. There are from where to where? From 0 to 100 you're finding, right? So that's why the interval is from 0 to 100. And then the area equation is found out, and put this in calculator directly and you can find the answer. Or you can solve it using the formula which we have used in the last lesson. In the previous video, in one of the problem we had solved by using formula, same type. Or you can directly use calculator. Over here, this symbol, open the bracket, minus 9 divided by 5 plus, okay, I forgot to write the x, alpha x plus 180 the whole square. And over here, it's from 0 to 100. And that is the answer. It is, the volume is 1,080,000 meter cubes. So this is the answer. Why? Because the units is in meter. Similarly, let's solve one more problem, computing the volume of a dome. Over here, they have told, suppose that a dome has a circular cross section. In your mind, you must remember this is area is pi r square. This is given. With outline y equals minus 2 by 45x squared plus 90 for negative 45 to 45, the limit of x, in units of centimeters. The graph is shown in the figure. Find the volume of the dome. So this is the graph given. We need to find the volume of this dome. Now look over here. In this problem, there is a little bit of difference because the circular cross section, we have to find this entire volume. Now when we see the cross section over here, see this one, this is the cross section they are given. What is happening here? This is the part you're finding. So you need to find all the cross section along this point to this point. Okay, so if you cut this like this into various points, basically you're integrating. See, one, if you find one, it's enough. From where to where? You're integrating from 0 to 90. Okay, in this case, see, this is the cross sections. For all these, you need to integrate. If you find one part and integrate, that means you're finding all over here, all the cross sections, sum of that. So what you need to remember, don't just go with this limit. Oh, the limit is 45. No, you need to take along the y-axis. That is very important. Now, we will just solve the problem. You'll understand better now. Analyze the graph. The cross section occurs along y-axis. This is the main reason. Now, in case if the graph was like this and you are to find the volume, then yes, this and this would be the interval along the x-axis. But now it is along the y-axis, isn't it? The cross section over here, see? This one, this is the radius from year to year. So remember, we need to change the question, everything, even the formula will be changed. It won't be a of x, it will be a of y. Why? Because this axis is used. If it was like this problem, then yes, we would have taken a of x. That is the difference in this case. So now over here, the limits will be from 0 to 90, okay? And we have to integrate with respect to y. This is one more crucial thing. To find the cross-sectional area, y is equal to minus 2 by 45x squared plus 90 is given, but this is not the thing. You need to rearrange, take x to one side and y to the other side. Why? With respect to y, we will solve a of y. That means x is equal to in terms of y over here. So take everything to the other side and simplify. We are just doing basic algebraic calculations. Over here 90 minus y, this to the other side. Take the 45 and 2 to the other sides and take the square root of this. That's it. Very simple. Now, this is basically the radius, okay? So now this, whatever is given is mentioned, this is the equation. Now, what do we do? Now, all we have to do is put it in the formula of area. Pi r square. Now, r is found out. This is the r equation. So this will be your equation for the area. A of y is equal to pi into this radius, the whole square. Now you need to use the formula and solve, but in this formula, the interval a to b is 0 to 90. A of y, what is this? Substitute over here and dy. Put it in the calculator. Very, very simple. Just now what we did, same thing you need to do, just that use the brackets properly. Okay, just, sorry, over here. This shift pi and use the brackets, use the square root appropriately. This 45 divided by 2, multiply it with 90 minus, instead of, you can't have dy over here, just use it x, but you must know that is y over here, and use the bracket appropriately and then square, and the limits are from 0 to 90, and this is your answer. That is basically 28627. That's how we can solve it. Very simple, very straightforward. Just remember which axis you're integrating. That's how you can directly use a calculator, but the formula changes depending on the axis.